All right, final exam cheat sheet. Wrapping up here with numbers 17 and 18. This will be the last clip from our final exam recordings. Number 17, shown right here, you're going to be given a cone. And this is going to be referenced to Chapter 11, Section 6, which dealt with cones. And the name of the section dealt with both surface area, a two-dimensional measurement, and volume of cones. In this problem, you're going to be dealing with surface area. Surface area is a two-dimensional measurement, and it deals here with the amount of material required to make this cone. And it's really split up into two different things right here in this diagram. I have a circular base, which finding the area of a circle is just pi r squared. And then I'm going to have what we call lateral surface area, or the amount of material required to make this cone that's going to spiral around this circular base. So we are given the formula to surface area of a cone in 11.6, and it's as follows. It's split up into two pieces. We'll call surface area capital S. But piece number one, the circular base, is determined by pi r squared. This is, again, the area of this circular base. But the other piece here is determined by pi r cursive L, what we call slant length. This, again, gives me the area of the lateral surface area, the side of what's going to make the cone itself, so to speak. So these two pieces, you'll notice both have this r term right here. R here is represented by the radius of the circular base. So fundamentally, we're going to have to convert this 8-unit diameter into its radius counterpart. But the other piece here is this cursive L. L is slant length. For us, that's just going to be the 6-unit length right here. Slant length, or cursive L, is the distance from the apex, or top of the cone, down to its circular base. And so the 6 units here is this cursive L, the slant length. You'll see the same sort of information given on your number 17 on your final exam. And then, again, we'll be solving for this guy in this problem. So actually, the first thing we need to do, it's a simple step, but I need to convert this 8 units into its radius counterpart, and that's a simple conversion. I just take the 8 units and cut it in half, divide by 2, because diameter is simply double the length of radius. 8 divided by 2 here is 4 units. This is my lowercase r radius of the circular base. So this 4 units is what's going to go into these two locations. Well, at this point now I'm just plugging in those values. This 4 units is going to go in for r. This 6 units is going to go in for the cursive L. And then just have to combine my like terms. So S here is going to be pi times that radius squared. Radius here is 4 units. So I'll just have to be careful of order of operations as I work through this. And then for the lateral surface area, that r is still the same r, the radius of the base, so 4 units. And then slant length here is this 6-unit apex to base distance right here. So at this point, now it's just doing the math, the button mashing on your calculator. Again, the one thing that I want to emphasize here, the one mistake that a lot of students make is that they do pi times 4 before squaring it. Order of operations dictates that I have to do this first before anything else. So 4 squared, or 4 times 4 is 16. That's 16 times pi gives me, that looked bad, 16 pi. There we go. This, for the record, is the area of the circular base. And then the lateral surface area that I'm going to be adding here, 4 times 6 is 24, times pi, we'll just make that 24 pi for right now. Technically speaking, you'd multiply this by 3.14. There's very little consequence that would happen in this case. But just to kind of show how I would do the exact solution here first, at this point, technically, I can combine these like terms. They both have a pi attached. So 16 plus 24 gives me 40. There is a pi attached to it. This would be what we call the exact solution. You'll be asked to round this to the nearest hundredth, or 2 decimal places. So I just wait to round to the very end. So 40 times 3.14 for pi gives me the following. If I'm going to 2 decimal places, technically this would be 125.60 for the surface area of this cone. And whatever units it would be in square units, because again, we're talking surface area. This is the amount of material required to make the cone that we're provided. There's problem number 17. Essentially, again, boiling down to just plugging values in. You'll have to convert to find radius. That will be the value that goes into both of these places. And then you'll be using the slant length, whatever you're shown there, distance from the apex down to its base. Just remember that, again, you first have to do the radius squared in this calculation. Everything after that should be pretty straightforward. But there's number 17. All right, moving on to problem number 18, our last problem on our final exam for the second semester. All right, this last problem will come from the last section that we dealt with in our textbook, 11.7. 11.7 dealt with surface area and volume of spheres. Okay, and so you're not even going to be shown a diagram in this case. You will be told the surface area of some sphere. And a sphere, again, is just a ball, pretty familiar shape to us. But you're going to be told in this problem that you have a surface area of some given number. In this case, for the sake of this example, we'll say it's 324 pi, and then to put in a unit, we'll say it's square centimeters. Again, area being square units. And so you will be seeing something like this. There will be a pi involved in the surface area that you're given. And what you're going to be asked to solve for here in this problem, your last problem, is the volume of the sphere with the given surface area. So to kind of convert this to a real life example, maybe this is a baseball, and the surface area is the amount of material required to make the exterior of that baseball, the leather on the outside. So based on the amount of material required to make the outside, you need to figure out how much material is going to be filling the inside of this ball. So this is basically going to break down to two phases. Number one, we're going to deal with the surface area. And surface area does have a formula that we found out in 11.7. It has the following formula. Surface area is 4 times pi times the radius of that ball squared. And the fact that we are given surface area here, this value is going to go in for S, and we'll backwards solve for radius. This is the first phase of this problem. I need to figure out the radius of this ball, this sphere, in order to use the volume formula. So I'm simply going to take the given surface area, 324 pi, and plug that in for S, and set it equal to 4 pi r squared. Because at this point, now I'm going to be solving this equation for this unknown radius. So just to show the work here, what I'm going to end up doing is I'm going to divide both sides by this 4 pi to start with. So divide both sides by 4 pi. The whole reason we do this inverse operation is because it's going to cancel here on that side. And then on the left-hand side, you'll notice that the pi's will cancel. That'll be convenient. Resist the temptation to plug in 3.14 from the very beginning. But when I do this actual inverse operation now, 324 divided by 4 breaks down to be 81. You can confirm that on a calculator. And on the right-hand side, all that's left over is this r squared. Another common mistake at this point, people think that the way that they get rid of this 2 is by dividing. This 2 is not multiplying, for the record. This is r squared. And so the inverse operation for undoing a squared is to take the square root of both sides. And when I do that, on the right-hand side of this equation, I'm going to get just r. It undoes the squared. And then on the left-hand side, the square root of 81, and this will be the same kind of result that you see on your test for your final exam. You'll get a nice friendly number. The square root of 81 is 9. You can confirm that on a calculator, but phase 1, find the radius of your ball. We'll use the surface area formula to backwards solve for radius. At this point, now we're in phase 2. We know the radius of our ball. So now we need to figure out the volume. And the volume is using the following formula. 4/3 times pi times the radius to the third power. The very same radius that we just solved for. So we're going to end up substituting this value in to that radius in our formula. This is how we end up solving for V, because this is the only piece we're going to care about for volume, radius. So when I plug that value in this case, I get 4/3 times pi, and now I'm substituting that 9 in for r to the third power. Order of operations dictates that I have to deal with this guy first. That tends to be the most common mistake. They deal with all this mess. But this is what I have to do first, 9 to the third power. And there are a couple ways I could do that. I could do 9 times 9 times 9. Okay, 9 times 9 times 9, 729. Or for the record, I could use this button as well. So had I started at the beginning, I could do 9 to the third power, using that button. Either way, I should get to the same result, and I get 729. So 9 to the third power is 729. That's really the one critical piece I have to take care of first. Everything else after this will be pretty straightforward. So 9 to the third power, that's 729. At this point, now I'm just multiplying straight across. Technically speaking, pi is over 1. 729 is over 1. I don't need to write that, but that's just to help me realize that I'm just going numerator to numerator to numerator, over denominator to denominator to denominator. So here, I'll be able to just jump to what my final answer is. You'll be asked to round to the nearest 2 decimals or hundredths place. So just to kind of run through this, I'm going to deal with my numerators first. 4 times pi times 729. 4 times 3.14 times 729. There's my numerator. Just remember that I'm dividing by 3. So after I go through that, I'm going to divide by 3. And there's my result. So my final answer here in this case is 3052.08. And since this is volume, my initial units were centimeters. This is going to be cubic centimeters. This would be my final result for volume, given the surface area at the beginning of the problem. So again, it broke down to 2 phases, just to summarize really quickly here. Phase 1, use the surface area formula to backwards solve for radius. Once I have the radius, phase 2, I'm plugging this value in to my volume formula. Make sure you deal with that cubed or third power version first. Once you do that, you just multiply numerators across, divide by the 3. There's your final result. And that concludes our final exam. I'll go ahead and start recording there.